So now moving on to something we call as the profitability index. Profitability index, or PI in simple, is very similar to the idea of NPV. Okay, so let me quickly show you here. So we know NPV, right, equals present value of benefit minus cost. Cost is already present value, right? It's in time zero. Time zero means present value anyway. So that is NPV. What about PI? PI is present value of benefit, exactly like for NPV. But instead of subtracting, we divide by cost. All right, so PI is also like the benefit to cost measure. Okay, here it is benefit to cost ratio. Okay, so profitability index is the ratio of the present value of the benefit to the present value of the cost. All right, so now can you tell me, this number must be what? At least for you to accept a project, you want the present value of benefit to be larger or smaller than cost? You want benefit to be larger than cost. We know that even from NPV criteria. So we want this number to be at least 1 or greater than 1. Then accept. If it is smaller than 1, reject. Right? Smaller than 1, reject. Okay. So that is what it says here, right? Decision rule. If PI is greater than 1, accept. If PI is smaller than 1, reject. Right? For example, profitability index of 1.1 implies that for every dollar of investment, we create an additional 10 cents in value. So when you subtract 1 from your profitability, so 1.1 minus 1, right? That's 0.1. So you can tell 10%, right? That 10 cents for every dollar is like 10%. That is your return, okay? Or additional value created by that project. Got it, right? More than 1, that any number in excess of 1 is the percentage added to the value of the firm. For example, let's say we found profitability index to be, let's say, 2.3. Okay, that's PI, let's say. What does this mean? This means you subtract 1 minus 1, that's 1.3. So you would say 103% was the value added to the firm. 103% of the value of the project was added to the firm. Okay, that's cool, right? So if it was $10,000 cost, that means your total cash flow from that project was 23,000. So minus the 10,000, that's 100. That's like $13,000. 13,000 is 130%. I hope you got what I said. If not, just feel free to ignore that, okay? But anyway, when you subtract 1, that's the percentage added to the firm. Okay, percentage value added to the firm. So, profitability index is the present value of benefit divided by the cost. And the cost should be in absolute value. Again, we want to keep it a positive number, okay? Moving on, based on Excel, like what we found earlier, present value of benefit is the NPV calculated in step 2 in the last example. Let's go back to the Excel. So we call calculated benefit. All that we need to do is to divide by cost. So PI, right, is the present value benefit divided by cost. That's the formula, okay? So PI therefore equals our benefit is this divided by our cost is this. Enter. So this is not in dollar. This should be just a number. Okay. So PI is just a number. 1.08. So what do? Do we accept or reject this project? So all that I did was I took present value of benefit divided by the cost. In the same previous example, what is the PI? The PI is 1.08. That's the answer. We accept or reject the project. We accept because it is more than 1. Also, another way of saying that is this increases the value of the firm by 8 cents for every dollar per dollar invested. For every dollar invested, the value of the firm goes up by 8 cents or 8%. Okay. All right. That's what that means. I hope that makes sense. If it does not, you can always shoot me an email. So let's look at the advantages and disadvantages of profitability index. Advantage, it is closely related to NPV. And why is that a good thing? Because we know NPV is the king. Any relation with the king is always good, isn't it? If you have a relation with a king, that's always good. Generally leading to identical decision. That's the reason why it's good to be related to NPV, because whatever NPV says, most likely PI also says the same thing, like here. Okay, so if your benefit is larger than cost, it will be a positive NPV, and it will also, at the same time, it will also be greater than 1. Okay, so generally, but there are times when they may not provide you the same answer. Okay, there are times. So let's see. So it says it considers all cash flows. We do not ignore any cash flows, right? Unlike payback period, even in profitability index, we do not ignore cash flows. We consider time value of money because we did discount our cash flows, right, to find the present value of benefit that we use, right? Easy to understand and communicate, right? Easy to understand. If your benefit is larger than cost, the number will be larger than 1, accept, otherwise reject. Useful and capital rationing. Capital rationing means you have limited amount of capital, limited amount of money that you can invest in projects, so it becomes useful. Okay, if you have limited amount of money to invest in a few projects, then this can be useful. Okay, so basically consider only the project that have higher than 1 PI, otherwise completely reject, right? Disadvantage, it may lead to incorrect decisions in comparison to mutually exclusive investment. It can conflict with NPV, not good, right? There can be conflict with NPV. Okay. So let's talk more about this. Okay. So here is an example of conflict with NPV. So let's say there is a project, right? Cost $10,000, cost $100,000. Okay. So these are two different projects. There is project A and then there is project B. The firm can take only one of these. Either it will take A. If it takes A, it cannot take B. If it takes B, it cannot take A. Oftentimes that's what happens, for companies. So let's say companies have a piece of land. So what do? Let's say they have two options. Either open, let's say, a convenience store with, let's say, gas station, or open something else. Instead of convenience store, what could it be? Let's say a pharmacy or whatever. I don't know, right? So they can do one but not the other. So in that case, if there is conflict, now it creates problems. So here, so let's say present value of all of the cash flows is $15,000. Present value of all of the cash flows is $125,000. So profitability index says benefit divided by cost. So 15 divided by 10, that's 1.5. Here it's 125 divided by 100, which is 1.25, right? And NPV says your benefit minus cost is 15 minus 10 is 5. 125 minus 100 is $25,000. So based on PI, you'd say PI for A is larger, so definitely the company should go with A, project A. But NPV says, hey, the benefit is larger than cost for B in comparison to A. Therefore, go with B. So there clearly is a conflict. All right. So what do? If there is conflict, we always go with the NPV. Why? Again, just to reiterate, NPV is the king. Right? Moving on. The other criteria, the last one, but definitely not the least. So it's called as the internal rate of return, IRR. So what's the deal with IRR? IRR, like payback period, is also a break-even analysis, okay, a break-even tool. So IRR is the discount rate that makes the NPV exactly equal to 0. So what discount rate should you use so that the present value of your benefit exactly equals the cost? Present value of benefit exactly equals the cost. that discount rate is called as internal rate of return. Okay, another intuitive way of defining internal rate of return is you could say something like this. Internal rate of return is the internally generated rate of return by the project. What the project internally, the return that a project internally generates. So what is the return provided by a project? That's it, in simple, right? Decision rule: accept the project if the IRR is greater than the required rate of return. Okay, so again, IRR is internally generated rate of return. If what the project is generating is more than or greater than what I require, then accept the project. Makes sense? For example, just to give you a quick example here. So let's say IRR for a project, let's say IRR is 15%. Let's say that's what we found. Okay, we calculated IRR and it's 15%. And our required rate of return on that project, given the level of risk, is let's say 12%. We require 12%. This project is generating 15%. Accept or reject? We definitely want to accept, right? If it's generating more than what I want, even better, right? Anything that gives you more return, that's always better. More return is always better than less return, right? So here it's simple, very intuitive. Whatever the return project is generating, if that is more than what we want, accept that project. Otherwise, reject the project. IRR is the most important alternative to NPV. So there was a research, okay, done on companies, what they use the most, right? Number one was NPV, what capital budgeting tool they use the most. So NPV was, I think, like 97% of the respondents, like the financial managers from corporations, US corporations, they said they use NPV. Over 90%, I think it was like 92, 93% said they also use IRR. And over 80% said they use payback period. Okay, so like 97%, 96, 97, 92, 93%, 96, 97 NPV, 92, 93% IRR, about 83, I think, percentage said payback period. Okay, so top three widely used in practice. So widely used in practice, intuitively appealing, the internally generated rate of return, right, versus the required rate of return. That's very intuitive. Based entirely on the estimated cash flows. What it says, what it's saying here basically is, in order to calculate IRR, you do not even need the discount rate, right? When you want to calculate NPV, you want to have that discount rate. In our example, it was 12%. And what if you come up with a wrong discount rate? What if it should not have been 12%? For that level of risk, what if it should have been 15%? Now you could come up with a wrong conclusion. With NPV, that is a big issue. The issue with NPV is the discount rate, right? How do we find a proper discount rate? But with IRR, that problem is not there. So that is one superior thing, one superiority of IRR to NPV is that it does not need the discount rate, right? Because it is actually asking what is the rate that a project is providing anyway. So it is independent of interest rate. That is what we just said. Your interest rate does not matter, okay, when it comes to IRR. So NPV versus IRR. So NPV, with NPV, you enter your discount rate of return and then you find NPV. Okay, but with IRR, you assume that NPV is 0, because again, that's the idea. So at what rate will your NPV equal 0? At what rate will there be no benefit and no cost? Sorry, no loss, no profit, no loss, right? So here we input that is 0, and then we go backward. We try to calculate IRR. So here it's easy. You take cash flow, you discount all of the cash flows, you find NPV. But here we do not know the rate, so we know the cash flows, we know what NPV should be. Now we are trying to go backward to find this rate of return that will make it 0, the NPV 0. Okay. So let's continue. So IRR is the discount rate that equates the present value of the project's future net cash flows with the project's initial cash outlay. That's what we just said. Cost equals the benefit, right? So your initial outlay is the cost equal the present value of all of the cash flows. So these are a future cash flow 1, cash flow 2, future cash flow n, right, divided by 1 plus discount rate. All that we are doing is to find the present value of the cash flows. And we are equating that with the initial cost. So when you do that, find the IRR, find this rate of return, right? So the bad news is this is done by trial and error until the appropriate rate is found. So you say, oh, it looks like our IRR should be 10%. And then you find the value of those cash flows. You will see, hey, it's not close to zero. Looks like we need to use maybe 12%, right? Not 10%, maybe 12%. And then you use 12% and then see if it works. If you say, hey, it still is not working, maybe it's somewhere between 10 and 12, maybe like 11%. Okay, so you will do that trial and error until the appropriate rate or IRR is found. Okay, that's the bad news, trial and error. But the good news is Excel does this for us. So what you could say to that is, yay! In fact, when I was in my undergraduate, that is how I calculated. I calculated using trial and error. There used to be these pages, with all of the discount rate that you need to use. So for this discount rate, maybe this would be our cash flow. For that discount rate, maybe this would be our cash flow. Okay, so trial and error, it would take time. It would take maybe 10-15 minutes to find the IRR. But with Excel, you can do it in like a minute. If you know how to do it, it will take you less than probably even a minute. Okay. So computing IRR for the project, the same project, right, that we are looking at. So Excel steps. Input all cash flows starting year 0, which means include CF0 as well. Okay, so until now, if you look at our NPV and then PI, we excluded CF0, right, when we input, because we wanted to subtract CF0 when we found NPV. We wanted to divide by cost when we found PI. But when you compute IRR, you need to include cash flow 0 as well. Okay, so IRR, just to make sure we don't forget that, include CF0. Okay, I want to write that just to make sure we don't forget that. Maybe put this on a different color, or maybe change the font, make it bold. Yep, right? So include CF0. So now what do we need to do? The same cash flow. So include cash flow 0. So I will just write all of the cash flow maybe here just for fun. So copy, paste. So now this is time 0, time 1, time 2, time 3, right? That's all, right? So we have only those cash flows. You do not want to ignore any. If the cash flows went for many years, you would want to include all of them, right? So let's calculate IRR. Equal IRR is pretty simple, right? For IRR, all that you do is equal IRR, double click that IRR or tab, it says values. So you just go here, select all of the cash flows starting year 0, right? 0 through 3. Close the parenthesis, enter. What? Okay, so now here is another thing that we need to keep in mind. Here, our cash cost is negative, so we need to input negative. While calculating IRR, we need to make the cost negative, okay? So maybe we want to include that too here. Oops. So here, don't forget negative sign for cost. So two things to remember when it comes to IRR is number 1, to include CF0, and then number 2, to include negative sign. Right? IRR is a little bit different or a little more complicated than other. Complicated, not complicated, but different, right? Because there is no complication here. So it says 16%. Of course, I don't trust Excel decimal places. So I'll go to home, number format. I want to increase the decimal place to 2. Now that's right. Maybe just delete this, just so we see. Okay, so 16.13%. So that is my IRR. Okay, so this project internally generates 16.13% rate of return. All right. Any question, comment? shoot me an email. So what does this mean? So to understand what is this 16.13%, let's look at this, what we call as NPV profile. Okay, so the relationship between IRR and NPV is given by NPV profile. So this part, right, is our IRR. How do we know this part is IRR? Because at IRR your NPV is 0. So this part, your y-axis is NPV, this is your discount rate, x-axis, right? X-axis is discount rate, y-axis is the NPV. And we said the definition of IRR is where NPV is 0. So at 16%, right, this is close to 16%, our NPV is 0. Okay, so that's the idea. And for any discount rate less than IRR, if your discount rate is less than IRR, your NPV will be positive number. The lower the discount rate, the higher the NPV. Okay, so NPV and discount rate, they have opposite relationship, okay, or call them inverse relationship. Higher the discount rate, I guess you know that inverse. You know this, right? We talked about this. I mean, the example I oftentimes give is like when you go to the store, let's say, or a mall to buy some, let's say, clothes, the higher the discount rate, the lower the price you pay. The more the discount, the less you pay. Same idea here. The higher the discount rate, the lower the NPV, right? So the lower the discount rate, the higher the NPV. The less the discount, the more price you pay, right? So here, the lower the discount rate, the higher the NPV. Okay, that is what it says. And the higher the discount rate, the lower the NPV. So before or at any discount rate lower than a IRR, your NPV will be positive. Hence, accept the project. So I will repeat this. If your discount rate or required rate of return, call it required rate of return or call it discount rate, same thing, right? DISCOUNT. So if IRR or discount rate is smaller than IRR, sorry, if RRR, right? If required rate of return or discount rate is smaller than IRR, then accept the project. Why accept? Because NPV will be positive. That's why accept. Got it? So just to make sure this is clean. Okay, so you got the idea. So if our discount rate is anywhere here, we want to accept the project. If our discount rate is here, we want to reject the project, because if the discount rate is lower than IRR, the NPV is bound to be positive. That is the relationship between IRR and NPV. Okay, the relationship between IRR and NPV is that what we just said. Okay, that is how the reality is. All right, so moving on. So decision criteria test. Is IRR a really good decision tool? What do you think? Yes or no? We know it is one of the most widely used tools, so definitely it's got to be a good criteria, right? It's got to meet the criteria test, right? So does the IRR rule account for time value of money? What do you think? It does, because IRR is also automatically discounting the future cash flow. Okay. At the IRR rate. IRR is the rate of return at which the cash flows are discounted such that the NPV equals 0. So the cash flows are being discounted. Excuse me. Does it account for the risk of the cash flows? Again, the same idea. Okay. And another way to look at that is when so this is the IRR. If we are evaluating a less risky project, maybe our discount rate, let's say, is 12%. So then you would say accept, because our required rate of return is smaller than IRR. But if it is a risky project, let's say our discount rate would be 18%. Then we would say reject, because the discount rate is larger than this IRR, right? So accept here, reject here. So this is a less risky project. That's why 12%. This is more risky project. That's why that's 18%, right? So that's the idea. Right. So basically what I mean to say is with IRR, you can use the discount rate that gives based on the your required rate of return, which is based on the riskiness of the project, right? So yes. Does it provide an indication about the increase in the value? So it kind of does indirectly, not directly, because directly you would say IRR is the rate of return that makes your NPV equal to 0. So if NPV equal to 0, then there is no increase in the value of the firm, right? But then we know that if we know IRR, then we also know whether or not a project does provide higher, increase the value to the firm. For example, again, if our discount rate is 12%, if that's what we said, then we know this project adds value to the firm. So indirectly, IRR does give you a way to see whether or not the project adds value to the firm. Okay. So does it permit project ranking? It does not. Okay. So the why it does not, because let's say there are 3 projects. Okay, let's say one project has discount rate 12%, another project has 13%, let's say another project has 14%. What IRR says is except this, except that as well, because all of them are less than IRR, so the company should accept all of the project. But what IRR does not say is which one of these 3 projects actually provide the highest wealth to the firm. Which one of these add the most wealth to the firm? IRR does not say that. So we do not know which one of these provide the highest wealth. We do not know. That means we cannot rank the project. Which one is okay, fine. We should be accepting all. But if I want to rank, if I want to select only one of these 3, which one should I select? I don't know. IRR does not tell you that. Okay, that's the problem with the IRR. So if that's the problem, should we consider the IRR rule for our primary decision criteria? This one thing is like a bummer. Okay, so you would say nope, not as a primary, but very likely probably we do want to use IRR as a secondary tool. Then what do we want to use as a primary tool? What did we say? We always want to use the NPV. Okay, NPV is our ultimate decision rule. Even if everything else fails, NPV does not fail. Alrighty. So IRR advantage, it is preferred by executives. Why? Because it is intuitively appealing. What is the internally generated rate of return from a project? It's easy also to communicate the value of a project. If the rate of return provided by the project is more than what you want, then it adds value to the firm. Okay, except the project. And if the IRR is less than the expected rate of return or the required rate of return, then reject. Right? And if the IRR is high enough, may not even need to estimate a required return. So what it is saying is, normally what we do is we compare this IRR with our expected rate of return, right? These are our expected rate of return. If the expected rate of return, or if IRR is more than the expected rate of return, accept, right? And if you look at this 16.13, okay, so let's say you examine this project and it says your IRR is 16.13, then you may not even need to look at these. What are our actually required rate of return? Because 16.13 is already a very high rate of return. Let's say you might feel that way. For your type of company, let's say for Walmart type of company or Safeway type of company, 16.13 is like already good return. Maybe it does not even need to go to look at its required rate of return for these projects because this is high enough already. Okay, and that's a good thing, right? It considers all cash flows. We did not ignore any of the cash flows, right? When you compute IRR, you include all of the cash flows starting year 0 all the way through, all of your cash flows, right? It considers time value of money. It does discount the cash flows at the rate of IRR, right? At the internal rate of return. It does provide an indication of risk. So there are a couple ways to look at that. If the IRR is very high, then probably also automatically that this project is risky because it is giving you very high return. Higher return very likely means higher risk. And alternatively, another way of looking at that is you could compare IRR with your required rate of return, which would be taking into consideration the risk. So that's another way of looking at that. Okay, right? So what about the disadvantages? So IRR also has some disadvantages, as you already know, right? So number one was can produce multiple answers, right? If cash flows has sign change, easy cash outflow in between, then it can give you multiple IRR. Okay, so what that basically mean is, let me go back to a few slides back. Yep, right here. Here. So here, right, we have one sign change. One sign change means it was negative, right? The cash flow 0, cash flow not is negative, and then it's positive, right? When there is nothing, that's positive. So this is one sign change. So when there is one sign change, you will see one IRR, this internal rate of return. There is just one, 16.13%. But let's say if it were to be something like this, let's say negative here. Okay, so this is one sign change and then plus, right? And then again negative. So there is two sign change, one sign change here, another sign change here. If there are multiple sign change, there can be multiple IRR. So in this case, there would be like two IRR. So your IRR is 16.13. Maybe another IRR would be, let's say, 24%. So now it's confusing. Which IRR do I use to evaluate the project, right? So when there is multiple IRR, it can create more confusion. Okay, that's one of the big disadvantages of IRR. Okay, so that's what it says here. The other one, which we already talked about, is it cannot rank mutually exclusive projects because, again, just to reiterate this, if you have 12%, 13%, 14%, and then IRR is 16, IRR says accept all of them because the required rate of return is lower than the IRR, or IRR is higher than the required rate of return for all of these three projects. But IRR, using IRR, there is no way to say which one of these three projects are actually is the best. Okay, which one is number one, which one is number two, which one is number three? We cannot rank using the IRR. Okay. In these two cases, when you have multiple cash flow sign change, right, and when you cannot rank mutually exclusive project, you want to use NPV. NPV is best suited in these cases, right? Go with positive. So if there are multiple sign chains, always go with the positive and the highest NPV. Always, that's what we want. Never go with negative NPV. Negative NPV. NPV reduces the wealth of the corporation or destroys shareholders' wealth. And go with the highest NPV because highest NPV adds the highest value of wealth to the firm or to the shareholders. Example of mutually exclusive project, and you can do this yourself. So let's say these are the cash flows 0, 1, 2. So this is like the cost, and these are like the benefit, and you can do this. Now you know how to calculate the IRR, you know how to calculate the NPV, and you can find this yourself, right? So when you find this, these will be the numbers. IRR, you will get these IRR 19 and 22. When you compute NPV, you will get 64 and 60. So which project should you accept and why? What do you think? So between project A and B, if they are mutually exclusive means if you take one, you cannot take the other. So can you tell me which you should accept? You should accept project A, right? Always go with NPV. Whenever there is conflict, always go with NPV. IRR says go with B because B IRR is higher, but NPV says go with A, always follow NPV. NPV is the king, right? Capital budgeting in practice. In practice, what do you do? How do corporations apply capital budgeting in practice? Okay, so consider all investment criteria when making decisions. So it says, look at all these four. Maybe there are a few more. Maybe look at all of those and see, which of those criteria are speaking the same language, right? NPV and IRR are the most commonly used primary investment criteria. If you recall, over 90% of the finance managers use NPV and IRR, right? Payback is a commonly used secondary investment criteria. Over 80% use payback period. All provide valuable information. Okay. So example of project analysis when projects are independent. So let's do this for each of these projects. So for project A, B, and C, can you do it? Do you want to pause the video and find all of those four? Find payback period, find NPV, find PI, find IRR for project A, and then B, and then C. Do you want to try for each of these projects and then come back? So I hope you paused and now you're back. So let's do this, right? So I will put all of the cash flows here for project A. Let's type project A. And I will type time 0, 1, 2, 3, 4, 5, because it goes all the way through 5, right, for all of the project. So I will just type 5. Okay. And then here, let's say I'm calculating NPV. So let's write a rate here. Rate is given to be 10%. So now let's calculate here NPV. Okay, equal NPV. That's what we're doing, right? And but before that, of course, I need to input the cash flows, which I haven't done. So let's write a date here. Okay, that's rate. Or let me put one more space here. I will just cut. I just did cut. I will paste it here so that we have a place for rate here. Okay. And our cash flows should be here minus 10,000, or let's put 10,000, right? 5,000, that's 50. Let's do 5. 5,000 as well. 2,000. That's it, right? And if you recall, when we are calculating NPV, let's do this. Okay, let's keep the cash flow 0 separately. If you recall, for NPV and for PI, we want to keep the cash flow 0 separately, right? We do not want to mix that with the other cash flows. So I will put that here, 10,000. I will put that as a positive number because for NPV, we want to subtract a positive number. For PI, also, we want to use a positive cost, right? So now, equal NPV, it is asking you for rate, that's rate, comma, it is asking you for values. These are all our values, only up to year 3 for project A. Enter, right? So this is not NPV, actually, this is PV, PV of benefits. That's what it is, right? Present value of benefit. Now NPV equal present value of benefit minus cost, right? All of you with me so far? So NPV is present value of benefit minus the cost. Enter. So that's $180.32. That's NPV. Okay. Let's find PI. PI is present value of benefit, right, divided by cost. Enter, right? And I do not want this number to be in dollar sign, so I will just change that into number format because PI is not in dollar. PI is just a number without a unit. And then IRR. IRR is equal to, you do IRR, but for IRR, we know we need to keep a couple things in mind. We do need cost, and we do need the cost to be a negative number. So for IRR, what I normally do is, not to confuse myself, I will just copy, right? I will paste it here. But for time 0 also, we need cash flow. When it comes to IRR, recall that we do need cost, and we do need cost as a negative number. So that's the difference for IRR. Okay, so now I will just calculate IRR here, equal IRR. Just select all of the cash flow, right? If you wonder, what I just did was I did equal IRR and then double click, just select all of the cash flows. So it's only those, close the parenthesis, enter. So it says 11%, but that's not enough. I want there to be at least 2 decimal places. 11.16%. Now that's good. Alrighty, so that's IRR. We did not calculate payback period. Let's calculate payback period as well. Okay. So for payback period, what we could do is, let's see, for payback period, I usually like it normal pays. So let's use this here, okay, for payback period. So I have, or we can just use Excel, you know, when we have Excel, why not use Excel, right? Pay back. So we have minus 10,000. I want to input all of the cash flows, 5,000. 5,000, I guess 2,000, and then find cumulative here. So let's cut paste here. I want to call it cash flows. I want to call it cumulative, and for cumulative, it's for the first year is the same number. For the second year, it's equal to this plus this number. For that, this is equal to this plus that number. I think this is 50,000. I should be keeping 5,000, right? So whenever it becomes positive, you can stop, or whenever it becomes zero, you can stop when it comes to payback period, right? So our cumulative here, right, it became zero. So what does it tell you? It tells you that your payback period is exactly this. This is payback period, right? This is 0, 1, 2. So your payback period is 2 years. I know the question here is not asking you for payback period, but I wanted to show it to you anyway. All right. So do you want to do the same thing for project B and then project C? Exactly the same way. If you do that exactly the same way that I just did for A, and I strongly recommend you doing that for B and C, you would get these answers. Okay, make sure please do try these. Make sure you get these IRR, NPV and PI, IRR, NPV and PI, okay, for these. Okay, and if you want the payback period for project B should be because it does not give you the payback period. It gives you the answer for NPV, PI, and IRR. It does not tell you what are the payback period for A, B, and C. So for A, we just calculated that to be exactly 2 years. For B, it should be 4,000. I will tell it to you, okay, right now. So that's 4,500, 5,500, 6,000. Unit 4 by 8, 5. So that should be 3.8 years. Right, just to confirm, I will just do pay back for B, right? That's what I'm doing. So CF is minus 10,000. That's 1,000 minus 10,000. 5,000. Sorry, 1,500 for project B. 2,000. 2,500. 5,000. 5,000. You need all of that, right? It's times 0, 1, 2, 3, 4, 5. And then now cumulative. For cumulative, it's exactly negative 10,000 equal this plus that, right? And then you can just drag it. I don't know if you knew that function, but you could. It does exactly what needs to be done when you drag the Excel function, okay? So when it comes to payback period, you can just stop whenever it becomes positive. So it became positive, you don't even need this. We completely ignore this part. So we know it became positive between year 3 and 4. So we know the payback is somewhere here. So we know payback is 3 plus, if you recall the formula, what I need, here I need to recover 4,000, right? On year 4, right, I need to recover 4,000, but on year 4, I could recover 5,000. So that's 3.8 years. All right. So this was Control P. So payback, here it was 2 years. It's 3.8 years. And for the last one, it's easy, right? For the last one, it's between 1 and 2. So I could just do it here. So it's 1 plus you need to recover 2,000 because you recovered 8,000 already, means you need to recover 2,000, but you could recover 3,000. So that's 1.66. And this is just for practice, okay? All of these. So if you know how to calculate NPV, PI, IRR, and payback for all of these projects, probably you would know how to do all of the problems in this chapter, right? That's the whole idea. Okay, so please make sure you get all of these numbers. So now our question is, which project should you accept? So here, if you look at NPV is saying project B is giving you highest positive cash flow. Profitability index usually follows NPV, so it is also saying go with project B. IRR is saying go with project C. Payback is saying, with payback, you want the highest number or lowest number? You want to recover your cost sooner or later? You want to recover your cost sooner, right? So payback period is saying go with C. So 2 are saying go with B, 2 are saying go with C. What do you do? Which one do you go with? Always go with NPV, right? It is saying never go against the king, right? You do not want to go against the king. Why? Because you want to protect yourself, right? If you go against king, no clue what kings will do, right? Anyway, so always go with NPV, go with project B. All right, that's it. So okay, so now we are just doing some summary of this chapter. Okay, NPV summary. We know what NPV is, net present value. Net present value is the difference between the market value or present value of inflow and the cost. So find the present value of present value of all of the future cash flows, subtract the cost, except if NPV is greater than 0. NPV generally has no serious flaws, right? Preferred decision criteria, right? It is considered to be the king, of course. Internal rate of return, the discount rate that makes NPV exactly 0. Intuitive way of looking at IRR is internally generated return. What is the return this project is generating internally, right? Except if IRR is greater than the required rate of return. If a project is generating more return than what I require, except, right? And same decision as NPV generally with conventional cash flows. But if cash flows are not conventional, like multiple sign change, then it's not reliable IRR, right? And IRR is not reliable with mutually exclusive project because it does not tell you how to rank project, which one is the best. All right. Payback period, length of time until initial investment is recovered, right? Break even. Except if payback is smaller than some specified target. The problem with payback is it does not account for time value of money. We do not discount the cash flows. It ignores the cash flows after the payback. We completely ignore those cash flows after payback. Arbitrary cutoff period, right? The specific target is arbitrary. Asked the wrong question, which is like how long to break even. The right question should have been how much wealth is being added to the firm by the project. Profitability index is benefit to cost ratio, except if PI is greater than 1. But it cannot be used to rank mutually exclusive project. All right. Additional practice answers on the next slide. So this is additional practice for you. Please do work on these and make sure you get these answers. Okay. So there will be questions similar to these on the test. So please do not ignore this part. The end. That's it. So we are done with chapter 7. Only one last chapter left for the term. Okay, so see you on the next chapter. Until then, bye-bye.